Now, the next thing that I did with Insight was to ask myself, well, is there any relationship between these two variables, percent of students who can do math well and percent of students who can read correctly? So Insight lets you do that because you can plot more than one variable. So I'm going to go over here, select first variable, I'm going to do reading, right? I'm going to go back to reading. And then I'm going to select a second variable. Second variable is going to do math. And again, Insight is a very smart piece of software, and if it sees that you're trying to visualize two quantitative variables, it will assume that you want to see the correlation, the relationship between those two variables. So I'm going to select math, and what you will get is what is called in visualization a scatter plot. So that's the scatter plot. The scatter plot shows you the relationship between these two variables. So on the x-axis you have math, on the vertical axis you have reading. The further to the right each dot is, the larger the percent of students on that school who could do math correctly, and the further up one of those dots is, the larger the percent of students who could read at grade level. So as you can see that in general, and that's the pattern that we have discovered thanks to the visualization, the further to the right a dot is, the further up it tends to be. That will be a positive correlation. The more you have from these, the more you have from the other variable. The correlation could be inverse, by the way. Sometimes you have more than one variable and less than the other variable. It could happen that the more students do math correctly, the fewer students can read well. That's not true, obviously, but it could have happened. That's something that we could also have discovered thanks to the visualization. So this chart is not that compelling, right? Because it's predictable that in general, if students perform well in some tests, they will also perform relatively well in other tests. There are several potential schools here that may be worth looking into. For instance, I saw this school over here in which fewer than 20% of students could do math well, but more than 55% of students could read correctly. So there is an imbalance between reading and math. What's going on over here? It could be perhaps that school puts a lot of emphasis in teaching reading, but not so much emphasis in teaching math. We don't know, but it's something that we have discovered thanks to the visualization. Now, the most interesting part comes when I did something else, which is to split the data up. Right? Before I get there, by the way, if you're interested in statistics, this is as an aside for those of you who use stats. Insight also lets you insert trend lines, right? So if you go to, and I describe these in the practical tutorials that come after these videos. So if you go to the Add to Plot menu up here, there is one menu over here that says trend lines and curves, and this will let you insert, for example, a linear model, right? A regression line there in the middle that shows you the overall direction of the data. And you can also insert quadratic lines or cubic lines, different kinds of trend lines, in case that the relationship between the two variables is not perfectly linear. Anyway, so I was saying that the most interesting thing that I discovered in this data set appeared when I did something else, which is to split the data up according to another variable. Remember that when we took a look at the data set, I mentioned that there is one variable in the data set called board district, right? Miami is divided into 9 board districts. These are geographic areas the city of Miami is divided into. I asked myself, well, right now on my scatter plot, I am seeing all schools together, right? All schools in Miami-Dade together into the same chart. What happens if I create one scatter plot per board district? Let's see what I can find in the data. So I went to Insight, and before I can do that, by the way, we're going to use the subset option, right? Subset by board district. But we cannot use it right away, because in order to subset the data correctly, Insight needs to learn that the variable board district is not a number, it is a name. It looks like a number because if you take a look at the variable on the data set, it's board district 1, 2, 3, 4, and 5. So, these software tools can be really, really smart, but in some cases they are really, really dumb. And when they see a number, they interpret that that is a number, that is a quantitative variable. 1 is less than 2 and 2 is less than 3. But that is not the case. This is a categorical variable. It's a name. So we need to tell Insight, please don't interpret this variable as a number, interpret it as a name. Board district 1, board district 2, board district 3. In order to do that, I need to go to manipulate variables over here on the upper menu, and I'm going to go to numeric variables, and I'm going to transform that variable from a number into a name. It will look the same. It will still be a name, but inside it's going to interpret that number as a name, not as a number, right? So I'm going to go over here and transform variables. I'm going to select the column that I want to transform, which is going to be board district, and I'm going to tell inside, this is not a number, this is a name, and that is done this way. You select board district, and then down here you say select transformation, and you say change to factor. That's just a fancy name for telling inside, please don't interpret this as a quantity, this is a name, right? So I'm going to change to factor, and then I'm going to click on transform. And once I do that, what inside will do will be to create an additional variable in the dataset called factors board district. And that's the one that we are going to use to subset the data. So if you click on transform, that variable has already been created. I can come back to visualize, and I'm going to go over here and tell the software subset by factors board district, and this is going to create 9 scatter plots, actually 10 scatter plots, because there is one school that doesn't belong to any of the board districts, belongs to board district 0, that doesn't exist in the data set, but all the other ones belong to board district 1, board district 2, board district 3, board district 4, 5, and so on and so forth. Now, when I saw this chart, I started visualizing many potential stories that we could pursue based on this very simple data set. So I took a screenshot, I downloaded this graphic, I click on PDF here, and I downloaded the plot to my computer. I opened it up in a software tool, and I started adding annotations, right? Things that I would be interested in learning more about from this data set. So here you have the same scatter plots over here with little circles and arrows pointing out things that I found compelling in the data. For instance, take a look at board district number 1. In board district number 1, most schools on that district are on the bottom left quadrant. That means that fewer than 50% of students read well, and fewer than 50% of students can do math correctly, right? So that's a pattern. Most schools are on that bottom left, but there's one exception. When we explore data with visualization, we need to focus both on the trends and patterns and the exceptions to those trends and patterns. So that's the reason why I put a little arrow over there. I said, well, we have a school in which students perform really well in math and reading in an otherwise relatively low-performing board district. So what's going on in that school? That could be a potential story. We have a great school, a school that looks great in an otherwise not so great board district. What is that school doing well? Or could it be that the students that come to the school already really well prepared, and that's the reason why they get better scores? We don't know. We don't have a causal explanation for this data to look like it does right now. But we have discovered an insight from the data, pattern and exception. Now, board district number 2 is very similar to board district number 1, with the exception that it's 3 schools that depart from the rest of the schools. These schools over here. Now, board district number 3, that's quite interesting as well. Board district number 3 is a board district in which most schools are on the upper right quadrant of the spectrum. What's going on? Most schools are up there, meaning a majority of students read well, and a majority of students also do math well. There are no schools on the bottom left, meaning there are no schools with a minority of students who can read well and do math well, right? And then board district number 7, which is the board district where I lived in, is like the mirror image of board district number 1. If on board district number 1, most schools were on the bottom left, with one great exception on the top right, board district number 7 is the opposite. All schools are on the top right of the spectrum, and there is one school down here, and you can notice that I put an arrow pointing out that school. So we have a low performing school in an otherwise great board district in terms of student performance in school. What's going on? We don't know, but we have discovered an insight. And then finally, you may notice that I circle board district number 6. I found that one really compelling and promising. The reason why that happened is that I saw that in most other board districts, schools tend to be concentrated either on the bottom left or on the upper right, low performing, high performing. But board district number 6, these schools over here are really spread out. And that's the reason why I mentioned before that when we visualize data for discovery, we need to pay attention at how much data concentrates or how much data disperses. In most school districts, data is concentrated. Most schools are either here or here or here. But in board district number 6, we have schools on the upper right quadrant and schools on the bottom left. What's going on? We have low-performing and high-performing schools in the same district. Both districts are relatively small geographic areas. So why do we see so much school inequality? The next step in this process was to design a map. I remember before moving to the United States that I read a lot of stories about school quality and income inequality and the relationship between income inequality and school performance. This is a relationship that exists in all countries that I am aware of and all the countries where I lived in. It happens in Spain, it happens in Brazil, and it happens also in the United States. It's only that in Spain, the relationship between income, high income, and school or low income and school performance is not as strong as it is in the United States, right? As far as I have read, right? Now let's put that to the test. Let's see if there is actually a relationship between school performance and income levels. So I went to the Census Bureau. I downloaded a data set of income, household income, area by area in Miami. I drew that map, and then I overlaid a map of the boundaries of the board districts. And I'm going to show you the charts that I created side by side with the map. And notice the patterns that we can discover over here. Board districts number 1 and board district number 2, which are the low performing districts, are very low income areas in Miami. These are areas such as, for example, Overtown and Little Haiti, which tend to be low income in terms of household income. Board district number 3, the third chart on this data set that we have over here, that's Miami Beach. Miami Beach obviously tends to be very high income. My own area has both high income and relatively low income areas, and that may explain that distortion in the data in which we have most schools on one quadrant and then we have a low performing school. Perhaps that low performing school is in one of the low income areas in my region. I don't know. That's something that we need to look into, right? And then the most compelling one that I mentioned before is board district number 6, the one in which all these schools are very dispersed. We have high performance and low performing schools. Now, that inequality in terms of school performance is reflected in income inequality. Board district number 6 is an area that contains at least 2 regions that are very, very high income. One of them called Key Biscayne, which is an island, which is very, very high income. And then on the mainland, you have a very narrow strip of land very close to the coast called Coconut Grove. And certain parts of Coconut Grove are very high income, right? But then on the other side of something, if you take a look at the map of board district number 6, you will see that there are very low income areas. It's like there is something that cuts the district in half. High income at the bottom, low income on top of that. That thing that cuts the district in half is US 1, all right? US 1, a road, cuts the district in 2 halves, high income and low income. Well, if I could explore the data further, the next step that I would do would be to find the coordinates, the longitude and latitude of each one of these schools, or I would use, for example, Google Maps to find them on a map, and then I would plot those schools onto the map to see whether the low-performing schools are on the low-income side of board district number 6, and the high-performing schools are on the high-income side on board district number 6. That will really, really show the evidence behind that claim that in developing countries and developed countries like the United States, that there's a very strong relationship between income levels and school performance. Now, while we are exploring this thing over here, and I'm going to emphasize again, a visualization never gives you the answer to anything. It just lets you discover features of the data. What we are visualizing so far are relationships. We cannot establish a causal connection between these two relationships. We cannot say, for example, that low-income families leads to low school performance. The relationship between those two variables could be much more complicated. We don't know why this relationship exists. The fact is that it does exist, and this may lead us to further explore the data and uncover even more things. The process of using visualization for discovery can be endless. We could continue just digging deeper and deeper and deeper into the data, finding other data sets that may supplement our exploration. We could also also contact experts, and that will be the next step that I would follow if I were interested in doing a data-driven story based on this data. I will pick up the phone, go to the education department at the university, talk to people who are experts on educational data in order to confirm whether any of these potential stories that I have uncovered in the data thanks to the visualization have any merit, or they are just the product of noise, which is something that sometimes happens when you explore data.